Good day, everyone. We are continuing with our topic, indices and logarithm. This time around, we are taking equations involving indices. We are starting with the simple linear cases. There are cases where the result of indices of a given problem become equations. These equations are sometimes simple linear or simultaneous linear, or sometimes it could be quadratic in nature. Whatever the equation may be, we are required to solve accordingly. Today we are treating simple linear cases. Examples. Solve the equation 2 raised to the power 7 equals to 8 raised to the power 5 minus s. The options are given: A, 5 over 8, B, 8 over 3, C, 3 over 2, D, 15 over 4. Solution. 2 raised to the power 7 is equals to 8 raised to the power 5 minus s. That's the given problem. We express the right hand side in 2 and its powers. That will give us 2 raised to the power 7 equals to 2 raised to the power 3. 8 is 2 raised to the power 3. Then we introduce bracket to guide the 5 minus s that was there before, the power of 5 minus s that was there before. Since they are in the same base, we equate powers. We have achieved the same base in the left hand side and the right hand side. So we can equate the power. 7 will now be equals to 3 into bracket 5 minus x. Then we'll close the bracket. Opening up the bracket, we now have 7 equals to 15 minus 3x. We calculate like terms together. 3x will now be equals to 15 minus 7. 3x will be equals to 8. Making s the subject formula, x will now be equals to 8 over 3. Another example. If 27 raised to the power x minus 2 is equals to 729, find x. The options are given: A, 3, B, 4, C, 5, D, 6, E, 7. Solution. Let's write out our given problem, which is 27 raised to the power x minus 2 equals to 729. Our target will be to raise both sides to the same base number and its powers. And in this case, if we look at 27, we know we can raise it to power 3 and 729. So we now have 3 raised to power 3. Then we introduce a bracket equals to 3 raised to power 6. Since they are in the same base, we can equate powers. So we now have 3 into bracket open x minus 2 bracket close equals to 6. We have just equated their powers. Solving. Open up your bracket. First of all, we divide both sides by 3 and you have x minus 2 equals to 2. Collect like terms together. X will now be equals to 2 plus 2. And that will give you x equals to 4. Another example. If 3 raised to the power 1 over y is equals to bracket open 1 over 27 bracket close raised to the power 2 over 3. Find y. The options are given: A, 2, B, 1 over 2, C, minus 1 over 2, D, minus 2. Solution. Let's write out our given problem, which is 3 raised to the power 1 over y equals to 1. We introduce our bracket 1 over 27 raised to the power 2 over 3. What we seek to do is express the right hand side in 3 and its powers to align with the left hand side. And that will give us 3 raised to the power y, 3 raised to the power 1 over y equals to bracket open 3 raised to the power minus 3. Then we close the bracket and bring our power that was there before 2 over 3. Now, we will seek to do the operation properly. We still write 3 raised to the power 1 over y is equals to 3 raised to the power minus 2. What happened there was that the minus 3 in the power, when it goes outside to multiply the other 2 over 3 in powers, The 3 will cancel out and the minus will affect the power of 2. Since they are in the same base now, we can equate their powers. So 1 over y will be equals to minus 2. And that simply means that we cross multiply, 1 will be equals to minus 2y. And making y the subject of formula, y will be equals to minus 1 over 2. Another example, if 5 raised to power x minus 3 all over 125 raised to power 3x minus 4 is equals to 1, find the value of x. The options are given. A, 1 whole number 1 over 8. B, 8 over 9. C, 7 over 8. D, 5 over 8. E, 0. Solution. Let us write our equation, write out our problem properly. In the numerator, we have 5 raised to power x minus 3. The denominator, we have 125 raised to power 3x minus 4 is equals to 1. Let us cross multiply to balance up our work. Then we now have 5 raised to power x minus 3 will be equals to 125 raised to power 3x minus 4. Next, we express the right hand side in 5 and its powers to be like the left hand side. So we now have 5 raised to power x minus 3 will be equals to 5 raised to power 3. Introduce a bracket because 125 is 5 raised to power 3. So we introduce a bracket to protect the 3x minus 4 that was there before. Since they are in same base, we equate the powers. So we now have x minus 3 will be equals to 3 into bracket 3x minus 4, close the bracket. Opening up the bracket, we now have x minus 3 will be equals to 9x minus 12. 3 just multiply values inside the bracket. That's why you have 9x minus 12. Then collecting like terms together, we now have 12 minus 3 will be equals to 9x minus x. Then result will be 8x will be equals to 9 and x will be equals to 9 over 8, which is one whole number 1 over 8. Another example, if 4 raised to power 3x over 2 is equals to square root of 8 raised to power x over 4, find x. Solution. We rewrite out our problem properly, which is 4 raised to power 3x over 2 equals to square root of 8 raised to power x all over 4. Proper presentation will show that 4 raised to power 3x over 2 is equals to 8 raised to power half x over 4. Let us try to express all items, both the right hand side and the left hand side, in 2 and its powers for uniformity. We now have 2 raised to power 2, we open our close bracket, that will be the value of our 4 in powers. Then raised to power 3x over 2 will be equals to, we know 8 is the same thing as 2 raised to power 3, so we introduce a bracket for that 2 raised to power 3 and we raise it to power half x that was there before. The denominator at the right hand side will be 2 raised to power 2. Now, since we've been able to achieve that, let us arrange properly. We now have 2 raised to power 3x because the 2 inside the bracket will cancel out the 2 in the denominator in the powers. And that will be equals to 2 raised to power 3x over 2 times 2 raised to power minus 2. When 2 raised to power 2, which is the denominator, come up to numerator, it carries the power of a minus. Now, our result will be 2 raised to power 3x will be equals to 2 raised to power 3x all over 2 minus 2. We have just applied indices there, raising everything in the right hand side to this 2 and its powers. Since they are in the same base, we equate powers. Both the left hand side and the right hand side are in the same base now, so we can equate powers. 3x will be equals to 3x over 2 minus 2. Yes, we collect like terms together, and that will be 3x minus 3x over 2 will be equals to minus 2. Solving the left hand side, we now have 6x minus 3x over 2 will be equals to minus 2. Then we can conveniently cross multiply now. We now have 3x because the result of 6x minus 3x will give you 3x. And that will be equals to minus 4. We just cross multiply 2 times minus 2 will give you minus 4. Thus, x will be equals to minus 4 over 3. Yes, another example. If let's introduce our bracket 4 over 3, close bracket, raised to power m plus 2 is equals to 9 over 16. Find the value of m. A minus 4, B minus 2, C 0, D 2, E 4. Solution. Let's write out our problem properly. 4 over 3, introduce our bracket, raised to power m plus 2 is equals to 9 over 16. Our target is to make the right hand side similar to the left hand side. So we introduce our bracket, 4 over 3 raised to power m plus 2 will be equals to 3 square over 4 square. 9 is 3 square, 16 is 4 square. Next, we move. That will be 4 over 3 raised to power m plus 2 will be equals to, we introduce our bracket, 3 over 4, close bracket, raised to power 2 is allowed since the power is the same. With this, we are near success. Next, let us invert the value at the right hand side, which is 3 over 4, to 4 over 3, and reflect it in the power. We now have 4 over 3, introduce our bracket, raised to power m plus 2 will be equals to 4 over 3 raised to power minus 2. What we have just done is mathematically correct. Since they are in the same base, we equate powers. We have achieved the same base on both the right hand side and the left hand side, so we can equate the powers. M plus 2 will be equals to minus 2. Thus, m will be equals to, collect items together now, minus 2 minus 2. That is, m will be equals to minus 4. Another example. If 2 raised to power 1 minus y times 2 raised to power y minus 1 all over the denominator now, 2 raised to power y plus 2 is equals to 8 raised to power 2 minus 3y. Find y. Solution. Writing out our problem, we now have 2 raised to power 1 minus y times 2 raised to power y minus 1 all over 2 raised to power y plus 2 is equals to 8 raised to power 2 minus 3y. Now, we can see a common thing there at the left-hand side, base 2, 2, 2. So, we express the right-hand side in 2 and its powers. That will give us 2 raised to power 1 minus y times 2 raised to power y minus 1 all over 2 raised to power y plus 2 is equals to 2 raised to power 3. That will safeguard the value that it was raised to before with a bracket, reduce bracket, 2 minus 3y. After that is achieved, applying the law of indices, we now have 2 raised to power 1 minus y plus y minus 1 minus, introduce bracket, y plus 2, then close your bracket. What we just did there is simple law of indices. We brought the denominator power upward, and that's why we introduce a minus sign there. Will be equals to 2 raised to power 6 minus 9y. We use the 3 to multiply out the value in the bracket, and that's why we have that result. Next, we do the simple arithmetic in the powers at the left hand side. We now have 2 raised to power 1 minus y plus y minus 1. Opening up the bracket, we have minus y minus 2 equals to 2 raised to power 6 minus 9y. By simple arithmetic operation, our result will be 2 raised to power minus y minus 2 equals to 2 raised to power 6 minus 9y. Equating powers, minus y minus 2 will be equals to 6 minus 9y. Collect items together, we now have 9y minus y will be equals to 6 plus 2. Our result will be 8y will be equals to 8. And that is to say y is equals to 1 because you divide both sides by 8. Another example. If 8 raised to power x over 2 is equals to 2 raised to power 3 over 8 times 4 raised to power 3 over 4. Find x. Solution. Let's present our problem properly. That will be 8 raised to power x over 2 equals to 2 raised to power 3 over 8 times 4 raised to power 3 over 4. Expressing all items in 2 and its powers, we now have 2 raised to power 3 we use a bracket to guide what was there before, which is x over 2, will be equals to 2 raised to power 3 over 8 times 2 raised to power 2. Then we introduce a bracket to guide the 3 over 4 that was there before. What we have just done, 8 is expressed in power, in 2 and its power, and that is 2 raised to power 3. Then 4 expressed, that is 2 raised to power 2. That is what we have just done. We have not done any harm to the system. 2 raised to power 3x over 2 will be equals to 2 raised to power 3 over 8 times 6 over 4. Applying the law of indices to the right-hand side power items, we now have 2 raised to power 3x over 2 will be equals to 2 raised to power 3 over 8 plus 6 over 4. That is the same as 2 raised to power 3 plus 12 over 8. That would be the same as 2 raised to power 3x over 2 equals to 2 raised to power 15 over 8. Since we have achieved the same base on both sides, we equate the powers. We now have 3x over 2 will be equals to 15 over 8. We are equating powers. Then we now have 3x will be equals to 15 times 2 over 8. Multiplying both sides by 1 over 3 to make s the subject of formula, we now have 3x times 1 over 3 will be equals to 15 times 2 over 8 times 1 over 3. X will be equals to 5 over 4. We've come to the end of our examples. We are taking our exercises from page 80 of the new SSCE in Hidden Fact Mathematics. Try your hands on these exercises. Answers are provided in the answer section of the book, either the hard copy or the soft copy. Thank you.